Welcome to online classes of Malabar Engineering College. Today we're gonna discuss about a problem which is based on a ball bearing. Okay, before which I telling about a ball bearing, what is meant by bearing? Bearing is a device that reduces the friction of a shaft. Like when we apply a shaft and when you place a bearing and when you place a rotary component above it, it will rotate without any friction. For that purpose, a bearing is situated in a mechanical devices. Okay, here let's discuss about a simple problem. In a particulate application, the radial load acting on a ball bearing is 5 kilonewton and the expected life for 90% of the bearing is 8,000 hours. Calculate the dynamic load carrying the capacity of the bearing when the shaft radius shaft rotates at 1450 rpm. Okay, so there's a ball bearing and it will be rotating. So there will be like 90% of the bearing hour is 8,000 hours, like it's 90% of the capacity. Okay, here we need to find the dynamic load carrying capacity when the shaft of radius, which is like shaft of rotating speed, which is given like 1450 rpm. Okay, first we write the given data. First we have force is like Ft equal to 5 kilonewton. Then we have life of the like how much time the bearing rotates, like the time, it's like around 8,000 hours. Then we have the speed 1450 rpm. Okay, these are the data which are given. Now first we need to calculate the bearing life, like how long the bearing will be running, the life of the bearing. For that there is an equation in the data book. LB is equal to 60 N into LF by 10 raised to 6. That is the equation. By substituting, we know from the N we know 1450, LF is 8,000 hour. By substituting that we get the value 696 millions of revolution, like 696 million times it can revolve. The bearing life revolves. After that the bearing get destroyed like that. Okay, after the second step is we need to type the dynamic load capacity, like how much load it can be applied on that bearing. From since the pure it's only the radial load, there is no axial load, only radially the load applies. There is no axis load. If there is no axis load, only the radial load is applied over here. So the force is equal to P. So since there is no axial load, only one load is there, that is the radial load. Okay, so it will be like P is equal to Ft into, that's given by 5000 Newton is the value, and we know the data book equation. C is equal to P into LB 1 by 3. On substituting it, we know the load capacity. The load capacity of the bearing is 44,310.48 Newton. That's the load capacity. After the load limit, after that load, the bearing will be destroyed. That's the meaning of the load capacity. By this, I wind up my class. Thank you.